ziet er prima uit hoor.
Ja, dat wordt zo. Ja, oké.
Zo misschien wat die aardig in.
Ja, ik bedoel meer van dat er ergens misschien een pinnetje geen... Ze net allemaal of niet wit, dat zou zeggen.
Ik denk dat het anti-aliasje is die de verkeerde kant op staat of zo. Goed, hoeveel tijd heb ik nou uiteindelijk? Hoeveel tijd heb ik uiteindelijk? Niet? Ik dacht dat ik wel wat zag op zo'n stuk, maar ik weet niet meer. Wat zei je? Oh, dan ga ik lekker rustig praten.
Ja, ik krijg heel dik. Zo wat VGA te maken hebben.
Oh, ik weet wat het is. Dat is
je...
Ja, dat is Redshift.
Redshift?
Ja.
Ja!
Redshift. Nee, Redshift is tof.
Ja, maar ga door.
Dat is waar.
Maar nee, dat is waar.
Ja.
Hier heeft het heel scherp aan.
Ja.
Zit, zeg maar. Dat je nu niet op de manier zit dat het progress.
Yes.
Ik kan altijd even op YouTube
Blooper reel. Oh ja, ik kan hem even klaarzetten, ja. Ja. Nope. Weet jij hoeveel mensen er nog aan het aan het maken zijn om te komen? Weet jij hoeveel mensen er nog aan het komen zijn? Dat weet ik namelijk wanneer ik moet beginnen. Straks, aan het einde. Alright. Hello? 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 Hey, hello, I'm going to start. If you want to continue having your conversations, don't, or stay here and listen to me speaking about this light thingy. There was no light talk about, there was no cube talk at Hackathon. All right, sure. All right, so I've prepared this presentation in English, so I'm just going to give it in English. Unless anyone objects? No. You object? No, I don't take you seriously. All right, so anyway, I'm Polyfloyd. I'm a board member of Hackerspace Bitlair in Amersfoort. It's a cool place where I do all kinds of cool stuff with electronics and software. Usually I'm more of a software guy, but last December I was at the Chaos Communication Congress in Leipzig, where I saw this thing. This is a cube made by Zaurik. You can find him on Twitter under that name. And he showed it to me. He showed me how he made it out of LED panels. It has a Raspberry Pi in it, and it has batteries. And it looks super cool. So I was like, oh man, I really got to have this. So I decided to make one of my own. And I found some other people that also wanted to join in. So we currently have a fellowship of the cube, consisting of 3 people. That's me, Sebastius from Revelation Space, and Book and Worm from Hackalot. And us 3 are currently building old cubes of our own. So it's a hardware project, but still, I'm not really involved in the hardware. Sebastius really likes working with hardware, so I just let him do his thing. And I'm more on the software side, but I still want to give a brief overview of the hardware that's here on this table. So Sebastian made a nice frame made with REST-based dual laser cutter. Designed it himself. Just unscrew all the frames that are prepackaged with all these LED panels. And screw them onto this wooden frame, so yeah, the cube. Awesome. Because I'm working on the software, I'm also concerned with like the mapping of where each panel is located. So this is how they are located. There are 3 strings of 2 panels each. 2 strings are on the sides, and 1 string is spread out over the bottom and the top. The colors match up here, so if you're interested in building one of your own and want to make use of my software, that if you stick to this schedule, then you'll probably be fine. But now, let's go to the software. This is a block diagram of all the software that I wrote or am using. It might look a bit daunting or complex, but we'll go over all these little pieces in a bit. So, the animations that you see on this cube are rendered in OpenGL. And OpenGL has this pipeline that goes from like a bunch of points to assembling those points into a polygon, maybe add a few more points to create more polygons. Then there's also a separate stage that checks whether some pixel is part of this polygon that we're trying to render. Then there's the fragment shader that does the coloring based on all this other information that we've supplied, and it's sent to the screen. This is a very interesting part because it's essentially a program that's executed for every pixel on the screen, and it's very, very, very much optimized. And some people decided that, hey, what if we just get rid of all of this stuff and create all of our geometry, our scenes, and our graphics all into the fragment shader states. That's what it's called. So people do that, and someone made this awesome website where people can play with and upload and remix all kinds of creations that are like rendered in this fragment shader. Now, keep in mind that everything you see here is not modeled by someone by pulling a bunch of geometries in Blender or 3ds Max. All these shapes are mathematically described, and that's what this allows. It allows each pixel to be like graphed over like a bunch of functions that return the current color for that pixel. And I thought that was cool, but that website only allows it to be displayed on that website or in some other program. So I've created a program. It's called Shady because it renders these programs called shaders that takes a shader source file, renders it, and it can render it to a video file or some device. In this case, the device is the cube. It can also take inputs from videos, images, audio. It can do audio visualization. It's really cool. I'm not using that for the cube, but that's for the future. And yeah, this is the kind of stuff that Shady renders. This is a shader that someone wrote, and Shady renders it to a video that I'm currently playing in this presentation. Now, to actually display stuff on these LED panels, all these LED panels are connected to a Raspberry Pi on which I run a program which are called CubeCAD. That makes use of an open source library specifically made for driving these kinds of LED panels. And I've adapted it in a very small C++ program to kind of glue everything together. It's like 20 lines long, very simple. The kind of interface that I'm using between Shady and CubeCAD is just a raw pipe, like a kind of thing that you just throw bytes through. You can read them on the other end. It's fairly modular, so you can let Shady render to a file, or let it render over Netcat or some other tunnel like SSH. And that really helps with development because it's so modular. I can take out like the Raspberry Pi part and hook up another renderer that I made to render just on my computer. This was the result of one day of hacking with the software that I made. This is a spacey animation that I pulled from like the Shader Toy website. That's being displayed on my cube. Keep in mind that I still had a very old frame here, so you can see that it's held together by rubber bands and Velcro. Excellent, yeah. So, but as you might be able to tell, not all animations are correctly mapped. There's some stuff missing here, like it doesn't really flow over the edge. So that's a problem that I wanted to tackle in the software. This is the process that I'm using for some of the programs that are currently rendering on the cube. I start with a flat image. That's the image displayed on the screen. I slice that up into 6 parts of 64 by 64 pixels each. And I take the X and Y coordinates, and based on the position on the image, I add a third coordinate, which is like the height, the Z index. And I map those 2D coordinates to a 3D space, and which is literal 3D space of a cube. So if you might, for example, have the 0 point over here and the 0, 0, 0, 0, 0, 1, or 0, 1, 0, for example, on another corner. So it's just a mapping of each pixel to a 3D space. And if you graph those coordinates into the RGB color space, you get something like this. So this is white, so the 3 coordinates are 1, 1, and 1. Here it's green, so that's 0, 1, 0. Or a combination which is green and blue, which is in RGB 0, 1, 1. And with this animation, I can determine whether my program works correctly and all my panels are correctly assembled. Then, to actually display like flat images onto this cube, I'm mapping it to a 2D space again. What I've essentially done is created a kind of imaginary sphere around the cube, on which I can project stuff. So the sphere is a single 2D surface that curves around. On this image, you can see how the space, or a 2D space, curves around the cube. And here, I can go back, maybe that will start the video. Yeah, there we go. I'm rotating around a single axis because it's 2D space. So now that I've got that working, I can display actual images. And here, I'm displaying a world map that's just a regular world map. But notice that Greenland on most world maps is really big. And that's because most world maps distort the space of the Earth's surface. That's especially true with the Mercator projection. But because I'm projecting back onto a sphere, this kind of this warping is inverted. So it actually looks like the world, except it has more corners. The next thing that I'm working on, this is currently the work in progress, is stabilization. So I want to be able to pick up the cube, shake it, and then the globe should just stay upright. If you want to learn more about this project, you can follow me on Twitter or read a blog post that I wrote. It doesn't contain all the information. I'm probably going to write a part 2 at some point. But for now, you follow me on Twitter if you want to know more. Does anyone have any questions before we get to a live demo? Yeah, you can ask questions in Dutch. When I download images or these shaders from this website, do they already have a predefined resolution? No, not always. Some shaders are programmed for high def screens, because most people have those kind of screens. In general, most programs map over a space that is defined as that goes from 0 to 1. So I can just stretch that 0 and 1 out and get rid of some pixels or put more pixels in between, so the image stays the same. Are the animations really big then? Yeah, they could be. That depends on the animation. But this one, for example, that's this one as well. Those look very similar on very large screens, very high resolution screens. Any more questions?
If you could afford a bit of overhead, wouldn't it be easier to run some type of game engine in the laptop and render a spherical high map to a texture and send the texture to the box?
Would it be easy to use a game engine to render a sphere on my laptop and send it to the cube? Is that what you're asking? Well, not really. I don't think it will be easy, because I already have most of that infrastructure in place. So creating a whole new system for rendering would make things more complex, I think. But the interface is there, so I could just swap around some components and without having to change my cube. That would be no problem. But I'm probably not going to do that. More questions? Sir.
How much bandwidth would you need from your laptop if you want to at some point replace it with Wi-Fi, I guess, because
how much bandwidth do I need to display an image on the cube in regards of a wireless connection. I'm using Raspberry Pi, by the way, Raspberry Pi Model 3, which has like Wi-Fi built on top of the board. And yes, I'm definitely going to make it work on Wi-Fi at some point, so I can get rid of these stupid cables poking out. I think I need about a few megabits, so not that much. Maybe it's a bit too much for Wi-Fi. I've already controlled it over Wi-Fi at some point, but eventually I'd really want to render stuff on the Raspberry Pi if it needs to be real time. I wonder if it's fast enough for that, but that's still an experiment that you need to do. The Raspberry Pi has a 1 megabit connection. It was fast enough.
Raspberry Pi 3B has just been released. That's a much faster.
I think that was the B3 Plus. The Raspberry Pi B3 Plus has just been released, and it has 5 gigahertz Wi-Fi. Yeah, I might consider that at some point. But yeah, currently I'm more working on getting the animations right still. But I see no reason to swap it, or to not swap it. Yes, it would be the best to have everything rendered on the box, or have everything ready on the box. More questions? Blooper reel. Oh yeah. So Sebastian gave a talk of his own about the hardware, mostly about the hardware. And well, when he was answering questions, he does this, or this happens. Ouch. Really hurts to see that. Let's see that again. Yeah. Yeah, YouTube can do slow motion. I'm very sorry, Sebastian, in case you're watching. But this costs too much to not show in slow motion. No. Four panels are broken and he needs to order some new ones. And find some new courage to start over. But luckily he has me and Boekenwer, so for support. I think I have quite some time left, so I'm working on this stabilization. Oh, do we have another question? Let's get it through that first. How heavy is it? Well, it's currently just a few, like, I think half a kilogram. Ooh. I could put it on a platform that levitates. If I put batteries in it, I cannot. But if I don't put batteries in it, it has to be in there forever, and I don't want it. I want to be able to carry it around and show it to people and impress people. So I'm not going to do that, I think. Still, it would also need a very big magnet, I think. More questions while we're at it? No? Okay. So I was working on the stabilization thingy. And I'd like to show you that, because still we have a lot of time left. It's not working quite as I wanted yet. I'm going to disconnect the cable now. But still, it looks pretty funny. So now I've connected this Arduino to my laptop. And if I stop my current animation, I can use Shady to load information from the Arduino. Like the Arduino is generating a transformation in matrix form. And OpenGL really likes to work with matrices. So I can just import that matrix directly into OpenGL, which is very convenient. So let's see if that works. Looks like it does. And if I pick it up, then after some time, the animation kind of follows the rotation of this Arduino. But that's still a work in progress. So, thank you for attending my talk. The Cube Earth Society has members in all corners of the world.